So let's get started. So at this point, you have everything you need for homework 1 up through objective 3. Sans the Docker stuff. We have half of the Docker. We have Docker, but not Docker Compose, and that's what we'll talk about today. So at this point, I would expect you to have the code for objectives 1, 2, and 3. Now, for objective 3, maybe you're still working on that. We just saw some of that content. But that's where I would expect you to be at. If you're not done with objective 3 or finishing up objective 3, you're starting to slip behind. There's still time to catch up, of course, but you should be well on your way on this homework. And then after today's lecture, you should be getting the Docker setup going. Get Docker all set up with Docker and Docker Compose, and then hit next week strong, ready to hit objectives 4 and 5. There is a difficulty spike going into objectives 4 and 5, so just be aware of that. There's, I would argue, not necessarily new content or more difficult content in objectives 4 and 5, but it really hammers down what we've already seen and makes sure you understand how to parse these requests and how to send responses in the proper format. You also have to talk to your database in objectives 4 and 5, so making sure you have your Docker and Docker Compose set up working after today's lecture. You'll be going into next week strong and able to finish this homework on time and getting full credit. So that's where we're at with the homework. And with that, let's talk about how to get that database going. No, don't do this. No, I know what happened there. That's fine. I just didn't refresh. I'm like, there's no way I forgot to push again. I can't do that 2 lectures in a row. All right, so Docker Compose and databases. We're going to use Docker Compose, but Docker Compose is a means to an ends to be able to get our database working and communicating with our app. So let's talk about it. Actually, I was going to say I assume you've seen databases before, but I guess I don't. I do kind of start at the top. But I won't talk about databases very much. I will either, one of the following, I'll assume, is either you've seen databases before, you've worked with them, and you're comfortable with them, or you can find the documentation and figure out how to use your database fairly quickly. And I'm just going to give a brief overview of 2 different databases, MySQL and MongoDB. All right, so a database is software that's going to run on a machine that's going... That first slide sounds pretty weird, but trust me, that means something. That's going to communicate with the disk for you. It's going to save files to disk. This is going to replace our file I/O. Instead of saying, open a file, write these bytes to it, open this file, read these bytes, the database is going to communicate with the disk, and we're going to communicate with the database to figure out what it should write to disk and what it should read from disk. And databases are typically very optimized. They're going to read and write from disk much, much faster than we could if we're writing our code, our file I/O code on our own. What I mean by it's software that runs on a machine, it's going to be a separate process running on some machine. For our cases, it's going to be a separate container running in Docker, but this could be a separate process running on any machine, and your program is going to have to connect to it. You're not running a database inside of your server app. This is always 2 separate processes, 2 separate apps completely that are going to communicate via TCP. Now, we're going to abstract the TCP layer. We're not going to handle database connections starting with the TCP socket. We're saving that for HTTP. That's what we focus on in this course. With the database, we're going to use libraries and just connect to the database. But it does use the same technology as our HTTP server. It's going to use TCP, create a connection, a TCP connection, and then communicate over that TCP connection to be able to send data to the database, get data from the database. It's all over TCP. Now, there is one exception to this. If you use databases we do this in 1.15, we use SQLite, which kind of violates what I just said. SQLite does run inside your program itself, and you don't have to have this TCP connection. It kind of abstracts all that away and just has a very lightweight database running in your process. And then you just send it commands, and it does its thing. Most real-world apps You're not going to use SQLite unless you're doing mobile development and you're talking to the local database on the phone. Other than that, you're going to have a database server, usually on a separate machine, connect to it over a TCP socket, and then communicate to that database that way. So we'll look at two different types of databases, MySQL and MongoDB. You're welcome to use any database you want. If you like Postgres and you want to use that, go for it. If you want to use something else, blanket on a fourth example, but if you want to use some other database, go for it. I'm going to cover these two, and just like with Python, I used to just say, here are your two options, choose these or some other database, whatever you do. As long as it's running in a separate container, so no SQLite in your code, you're defeating the purpose of what I'm showing you here. If you're using SQLite inside your code. But just like with Python, I'm actually going to recommend MongoDB. It's just less headaches. MySQL is fine. It's fantastic. Honestly, it's used extensively out there in the world. But it's just a little bit extra setup. There's a little bit extra overhead just to get to the point where you can put data in your database. Namely, you have to set up a username and password and have that username and password in your Docker container and also in your code and have it coordinated. It's just a little bit extra. It can go smoothly, but there are things that can go wrong with that. So I will recommend MongoDB. If you use MySQL, just know that you have a few extra steps to do to get to the point where you can use the database. So Python with MongoDB, it's, I'd say, the least amount of overhead and the least amount of, not learning curve, but setup curve to get everything running. Python and MongoDB will get you the quickest to the point where you can just start working on objectives instead of working on getting your environment set up. So let's start talking about MySQL. I'll still talk about both of these. Again, just a brief overview. By no means am I going into the specifics of databases. We got two fantastic databases courses here. You can take those to figure out what to do with what you can do with these databases, how they work, everything that's going on with these things. We're just going to insert some data into these and retrieve data. We're going to do very simple operations just to store pretty basic information for this course. We're not going to get too crazy with these databases. MySQL, again, this is software that runs on your machine. We will, the second half of this lecture, when I talk about Docker Compose, we're going to run these databases inside a Docker container. But if you're not using a Docker container, the first half, I'm going to assume we don't know what Docker Compose is yet. If you're not using a Docker container, MySQL, this is software that you're going to download, install, and run on your machine. It's a separate piece of software running completely independent of your app. Then your app is going to communicate with MySQL using TCP sockets. TCP, by default, listens on port 3306. That's the port that, just out of the box, you run MySQL. It's going to be running on 3306. You can overwrite that if you're so inclined, but usually just leave the default port, 3306. Then you're going to download a library for your language of choice that's going to talk to MySQL. That library is going to know that 3306 is the default port. So if you don't want to think about that port number, just leave the default. Don't tell any port to your library, and it's going to connect to 3306 on whatever host you give. If you're running it on your machine, localhost. You go to localhost 3306. That's where MySQL is listening for TCP connections, and it's listening specifically for SQL queries over that connection. The library, you download some connection library, that's going to handle all the TCP stuff. You're just going to give it a SQL query or a SQL statement, and it's going to convert it into TCP, encode it in bytes, all that good stuff, and send it any overhead, any headers that MySQL might need. It's going to do all that stuff and then send your query or statement over to the database over 3306. So we're not going to mess with the low-level details. Those libraries are allowed. Database connection libraries. There are a handful of libraries allowed in this class. TCP libraries, concurrency libraries, database connection libraries, JSON libraries. But if you're using Python, like I recommend, Python or Node, you won't need them because they're built into the language. and a few others. I'm blanking on the rest of them right now. Encryption libraries, and a few other that'll be relevant when we get there. I'll talk about them. So to establish a MySQL connection, this code is Scala code, but we're just talking about the concept here. No matter what language you're using to connect to your MySQL database, you're going to have to give it a few things. Your host name, localhost in my case, the database name, MySQL, which I believe is just the default database name, I didn't change it, and a username and password. Now, you should never do this. I had a whole slide on it, but I got sick of talking about it every semester. You should never put your password in your code, but just for the sake of example, I have the password in the code right here. You typically won't do that because then anyone who has access to your repo has access to your database. So everybody on the team has access to the database because they're going to go see the password and be able to connect to it from any machine. These are networked databases. Unless you're not allowing outside connections, which you really should not allow those. Don't put your password in that code like that. And then finally, connect. Again, libraries are going to be different, but host, database name, username, password. This is all the information that your library is going to need to be able to connect to your MySQL database. Once you're connected, you can start sending statements to the database using insert commands. Before you insert any data, you're going to have to create tables. So MySQL, it's a database. The database contains many tables as you want, and these tables are going to actually store your data. So before we can insert any data, we're going to need a table. I'm going to create a table named players with 2 columns or 2 fields, whatever you want to call them, username and points of type text and int. There are all kinds of different types. You can find some documentation, look them all up. But I'm going to create a table with 2 fields, and I'm going to use this if not exists. So whenever my server starts up, I'm going to run these 2 lines. I'm going to connect to the database. I'm going to create a statement. I'm going to write a statement that creates my table and does any of my initial setup. And I'm going to use this if not exists. So it's going to go to the database and say, hey, if this table doesn't exist, create it. And then say I'm debugging, I stop my app, I restart it, I spin my server up again. It's going to talk to the database again. Hey, if this table doesn't exist, create it. But at that point, at the second time, it already exists, so it's not going to do anything. The statement has no effect. If you don't have that, if you just do create table players, when you restart your server and it sends that statement a second time, SQL doesn't just say, oh, that table already exists. Let me just ignore this. No, it says, that table already exists. Let's crash. And your server crashes and nothing happens and nothing works. So make sure you don't forget that if not exists if you're running this on server startup every time. Once your table exists, you can start inserting data into it. We're going to create a prepared statement. Always, always, always prepared statements when you're inserting data, especially if this data is coming from a user. So assume this data, I just have it hard-coded here, but if this data is coming from a user, maybe this is the username that the player chose, the user chose, always, always, always use a prepared statement. I've seen this, this syntax is consistent over every SQL library that I've seen when you're connecting to it, is you have these question marks here in place of the actual data you want to insert. I'm inserting into the players table these 2 values for username and points. And then after we prepare the statement, then we're going to insert the data. So I'm going to insert the data of Mario and 10. When I do it this way, I'm specifying that Mario is a string and 10 is an int, which means this will only be interpreted as data. Then we're going to send off that statement. So what do I mean by that? What could happen if it's not just interpreted as data, as strictly a string? Well, your clever users are going to start writing SQL statements. Instead of a username of Mario or Peach or Toad or whatever, they're going to start writing SQL. Then your database gets this, your parts of the SQL statement, but so say instead of using prepared statements, you're just using string concatenation, concatenating the user, whatever the user inputted right into your statement. They're going to start writing SQL. If they're clever and malicious or funny or something, they're going to start writing this kind of stuff. What if they write drop table players as their username, and then they have a little extra SQL syntax to make sure it's a valid statement? Well, you just lost all your data. If you have a prepared statement, this will just be treated as a string, and that as a string literal will be the user's player name, the user's username. Prepared statements, always, always, always. These are very scary. SQL injection attacks, this is a security concern that we'll look for on the homeworks and on the project. This is a big one. This is your first big security concern. Prepared statements, always, always, always. And I would guess that at least probably half of you have seen this in another class before, at least one other class. We cover it in 115 even, and 199, I believe. You've seen this a few times. 365, of course, covers this. It's in a few classes. It's extremely important. If you graduate without internalizing this and always using prepared statements, then forget what I said. If you graduate without internalizing this, then we haven't done our job. You need to understand what SQL injection attacks are. And always, 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 if you don't see question marks in your SQL statements, you're doing something wrong. And you're opening up a big security hole. Whatever company ends up hiring you, if they don't have good code reviews to catch this, you're opening up them to a very huge security risk. Because clever users, if you don't have this, if you just have string concatenation inside there, oh man, a clever hacker can gain control of that whole server and just really, really destroy things. For example, if instead of a username, we say, go to the users table and give my username all the permissions. Well, now I got access to the server. I could have root permissions potentially, or at least to the database, and just start wrecking things from there. When you want to retrieve data, again, it'll be slightly different in each language, but you're going to send a query instead of a statement. Send a query, which is going to start with select. Select star from players means give me everything in the players table, which for this course, you can usually just do select star. Just grab everything and then write some code to filter out what you want or don't want and figure things out. When you get clever with databases and you take a databases class, you start really getting complex queries for your database, which is fun. It's just not something we want to focus on in this class because we got enough other stuff to worry about. So select star from players, give me everything, and then we can iterate over those results. It's going to usually give you an iterator like this. In some languages, it might give you a data structure, but it's going to give you all of the results of the query, and then we're going to do something with it. I'm just taking the result set and smashing it into a data structure by getting the fields one at a time, putting them in this data structure, and then after this, I have all of my data in a data structure, and after that, I'm outside of the world of SQL, outside of the world of databases, and I can use whatever Scala coding abilities I have to be able to do whatever the hell I want to do with that all scores. All right. Any questions on SQL so far? Nicholas, I assume you're keeping up on chat? Are there any questions in here so I'm not just staring at my phone for a while? Anything I got to address?
I asked if having a bad password is considered a vulnerability for the purposes of this class.
Having a bad password? I'm going to say yes, tentatively. If I can find out that you have a bad password, then yeah, I shouldn't know that you have a bad password. So if your password is hard-coded in your code and just sitting there plain for me to read, even if it's a strong password, yeah. But if I know you have a bad password, you did something wrong. because we're not going to take your hashes, your hashed passwords, and crack them. We're not going to go through all that because we got a lot of grading to do. We're just not going to take the time to do that on everyone. So if I know you have a bad password, then yeah, that's a bad, you messed up somewhere else. I forget you're not a TA in this class, so you actually have questions.
And then someone else asked if we're allowed to use like libraries to do sanitization for this, regardless of the database.
For the SQL injection for this, yeah. So this is a library right here I'm using. I don't have my imports there, but yeah, anything related to the database, you're allowed to use libraries, unless the database writes your queries and statements for you. So no ORMs, for example, which lets you just define a class, and then that class has like save and retrieve methods, and that talks to the database for you. You can't go that far, but if you're writing your SQL and the library takes it from there, then that's good. And if you look at I haven't really talked about the project yet, but if you look at the project description, I think I call it project requirements, that document, it has a list of what is and is not allowed. So anything that's allowed on the project without reports, I have a list of all kinds of stuff that's allowed without reports. Those are also allowed on your homework. So if you want a clear list of what is and isn't allowed, I update that list as students have questions that I haven't answered yet that aren't on those lists. I'll add that to the allowed or not allowed list. So if you have something that's not on that list, let me know so I can answer you and then add it to that list, one of those lists. All right, so yeah, I see the TA color in chat, and then I assume a TA's answering everything. I forget. I actually have to watch this. I'm on my own here. So you don't have to install MySQL or MongoDB on your local machine. I do recommend it, but if it's giving you too much trouble, you can get away without that step. I do recommend it just because Docker can take so long to spin up every time, and every time you make any change to your app as you're going through your debug process, you have to wait for Docker to start up again. So if you don't want to wait for Docker every time, you'll have to install your database locally and then connect to your local database during development, and then switch to Docker just for your finalization before you submit. So I do recommend it just to speed up the process, but if you don't mind waiting on Docker every single time, you don't have to. You don't have to install a database locally. I like using environment variables. That is plain and pluck. That is my typical solution. I'll put environment variables in my Docker Compose file, and in the repo, all my variable names for passwords will be change me. And then when I go to deploy, once I clone the repo in my production environment, then I'll go into that file and then change the password, change me into whatever actual password I'm going to have. That's my favorite way to do it. So I won't necessarily set environment variables on that machine, but I'll use my Docker Compose file. Just the way I ended up doing it. All right, so SQL is very structured. That's what the S stands for. It's a very structured database. You have to create tables. Those tables, you have to specify which columns it's going to have, how many, what types. And it can be pretty rigid. It's very hard to make changes in SQL. It's very similar to the structure of a CSV file. So what happens when we have this structure and we want, say, a key value store or just an array? Maybe we want a users table, and each user has their past orders. Maybe we want to store that as a data structure in the users table. We can't just jam a data structure into that format. It just doesn't work like that. So with SQL, the answer is to create a separate orders table and then use joins when you want to query, join those two databases based on the ID of the user to get all that data that you want, and then return that to the user. If you know joins or you want to learn joins, go for it. They're not too complex, but again, it's just one more thing. There's enough stuff to focus on in this course. So my favorite solution is just don't use SQL. Just use MongoDB. If you don't want to think about databases, again, if you're comfortable with databases and you have experience, by all means, do what you want. MongoDB, you don't have to mess with that. You just stuff your data in there and call it a day. So MongoDB, our other database that I'll cover, by default, 27017 is the port number. And just like SQL, MySQL, you're going to download your connection library. It's going to speak TCP on that port, connect to the database, and store your data. So the difference here is that it's going to be a document-based or unstructured database. When you insert data into this, if you're using Python or JavaScript, you just stuff your objects and dictionaries in there. If you're using Python and you got a dictionary, and that dictionary might have nested data structures, there might be a key for orders, for example, using my other example, you may have a key for orders that has a list of data, a list of objects, or a list of dictionaries that have other information, very complex structure. You just say, MongoDB, store this. You throw in the whole dictionary, throw MongoDB the entire dictionary, MongoDB is going to store that whole dictionary, no matter how nested the data structures are. So whatever complex structure you have in your objects or dictionaries, just send it to MongoDB. Let MongoDB worry about it. It's MongoDB's job. That's what it's here for. To connect, similar structure, except you'll notice the lack of a username and password. By default, MongoDB does not allow outside connections. And by default, there's no password protection on MongoDB. So you don't have to set up any password protection if you don't want to. And if you don't in this class, I'm fine with that. I'm OK with that. Because MongoDB is just not going to let people outside of the host machine connect to it, aside from Docker containers inside Docker Compose. So we're going to specify, oh man, I need to resize that. This is all one line. So to establish a connection, we do need 3 pieces of information to be able to get to our data. Actually, it's a little misleading. All you really need is this to connect. You need to give it the host name. By default, it will be localhost if you just say Mongo client. This is Python, by the way. If you just leave this blank, it'll connect to localhost. I'm going to be explicit because when we get to Docker Compose, that won't be localhost anymore. So don't copy this code, because that might cause you trouble down the road. Then we're going to connect. Once we're connected to the database, that Mongo client does all the TCP stuff. Then we want to connect to 2 different layers in the database. So the database server is going to have multiple databases, which can be just one for your purposes. Databases that you'll connect to the database using your client, using your connection. And each database can have any number of collections that you'll grab from that database. These collections are similar to the SQL tables, except you don't have to set anything up beforehand. There's no structure to the data. You don't have to specify your columns or anything. You're just going to stuff dictionaries into these things, into these collections. But you have to access the collection. If the database, the CSE 312, or that collection named chat, if those don't exist, Mongo's going to create them for me. So the first time I connect, Mongo's going to be like, oh, these don't exist. Let me create them for you. The second time I connect, it's going to say, oh, they exist. Let me just retrieve them for you. So we don't have any of that if not exists in table setup. We don't have any of that in MongoDB. And this is what I mean by just less setup overall. MongoDB is pretty easy to just spin up, connect to, and it works. We want to get data into this. Grab your collection.insert, and in Python, just give it a dictionary. Now, this data is going to be one record in my collection. And again, these can be nested. Message could be messages, and it could be a whole list of strings. It could be a list of dictionaries. It could be whatever complexity I want in this data. I'm just going to give it to the collection, and that's it. The collection is going to store that for me. For security, what about injection attacks? What about injection attacks? MongoDB doesn't care. MongoDB is not relying on string parsing to be able to interpret these statements. This is the terminology is document. This is a document. It has keys and values, and those are the actual values. They're not interpreted as MongoDB queries or statements at all. It's just all data. There's nothing to be parsing here, so you can't add any MongoDB code in here because that's already a string. These are already all strings in this case. There's nothing to inject here. So we don't have to worry about it. There's no vulnerability here. It's like we're always using prepared statements just by default. Yes, there are many drawbacks. I know the way I'm phrasing this is like MongoDB is great so far. It's not. It's just easier to get started. It's very great. I think it's great for beginners. I'll have a slide on that in a second. To retrieve data, we're going to use find and then give it a dictionary, and it's going to find any documents that match my key value pairs. So this query is going to give me every document with a key of username equal to Hartloff. So it's going to give me all of my chat messages. For this, if you want to get everything, the equivalent of select star, just give it an empty dictionary. Everything matches that. And it's going to give you everything in that collection. So it's really up to you to formalize any structure that you have in this collection. If you want every document to have a username, every document you insert in that collection, it's up to you to say, to make sure that they all have a username, for example. So it's up to you to enforce any structure. MongoDB is not going to enforce anything for you, just like SQL does. SQL will enforce, hey, you told me this table has these columns, you better give me that data when you insert something, unless you specify some of them as optional. So MongoDB, very unstructured. You just throw things in there, and it's up to you to enforce any structure that you may have. SQL is structured query language, very structured, tables, columns, rows, very hard to modify a SQL database. If you want to add a column to a table, very hard to do. You have to get into SQL migration. I shouldn't say very hard. It's not that hard if you're out there doing this stuff. But it's extra stuff you have to do to add a table to it. But SQL's very fast. It takes advantage of all that structure and is frickin' fast. MongoDB is pretty slow because there's no structure to rely on. It has to consider every possibility because anything could be possible with the data that's in there. So my hot take, MongoDB, really great for prototyping, getting an app started. You got an idea for an app, you're working at a hackathon or something, you're building something, some side project. MongoDB, that's a fantastic thing to start with. MongoDB is going to get you up and started fast, or homeworks for this course as well. We're not really concerned about every drop of efficiency. MongoDB is going to get you up and going. Plus, when you don't know the structure of your data, your structure is constantly changing, you're rapidly prototyping. MongoDB, you just put data into your collections in a different format. Bam, you just changed your schema. Very easy to change, very flexible, but it's not fast. Then once you have a bigger app, you're ready to go to production, your structure is settling down, you know what fields you're going to have, and you know what structure all of your data is going to have, then SQL is going to kick in. And the advantages of SQL, that efficiency, that optimization, that's going to kick in and be very beneficial to you. So once you're ready, you have a formal app, you're working for a company, most companies should be using SQL. That's the time to use SQL. So that's my hot take, that's my opinions on it. If you just have some pet project that you're working on and you're using SQL, unless you just like SQL, you're going to spend a lot of extra development time just dealing with SQL and building your tables and your schemas and all that. But once an app is big enough, you better be using SQL because you need that efficiency. So in this course, I said this at the beginning. I got to get to some Docker Compose. But I do expect you to find that documentation and figure out how to use the database. I'm not going to have any more lecture content on here's how you insert, here's how you delete, here's how you update a field. I didn't show you updating anything. I'll show you a little bit in Monday's lecture. And we have examples next week. I might end up, if there's time, in an example showing you. But I do expect you to be able to find that, read some documentation, figure out how to use these things. And I linked some documentation on today's lecture for MySQL and MongoDB. It's syntax. It's not too crazy. All right, any questions before we get into Docker Compose? I got to watch the clock more. I got a lot to talk about databases. Yeah, I would definitely use a relational database for scalable apps. Yeah, using any NoSQL on a large production app, like Google can't get away with MongoDB at their scale. Definitely can't do that. It'd be very, very wasteful. Just chilling. I like it. Did I say what we're using a database for in this class? Not explicitly yet. I will next week on Monday. But for objectives 4 and 5 on homework 1, you need a database. So right now I'm showing you how to get a database set up, and then on Monday I'll show you exactly what we're using that database for. But you will have to insert, retrieve data, update data, and delete data in your database of choice. So there are 4 basic commands that you'll have to use. All right, let's get to Docker Compose. I might have to go through this a little quick, actually. But Wednesday and Friday next week are reserved for examples. I'll show examples of all this stuff. I'll get in the code. We'll be in VS Code most of the time, Wednesday and Friday next week. All right, so we need to run 2 applications to run our app itself and the database. And how do we do that? Well, the answer is Docker Compose. So Docker Compose is separate from Docker. I think on some OSs, they just both install, like it installs with Docker. But you might have to install it separately and do your install of Docker Compose to be able to run this. When you install Docker Compose, we're going to have a separate file. You're going to have your Docker file and your docker-compose.yaml. YML. This is the YAML format. If you haven't seen it, it's a format that takes white space seriously, so this indentation does matter. This Mongo and app are part of services, and image is part of Mongo. Build, environment, ports are all part of app. Wait host is one of the environment variables we're setting. So the indentation does matter in this format. Other than that, its use case is about the same as JSON. It's solving the same problem. It's just a competing standard. And for some reason, JSON took over for web communication, and YAML kind of took over for configuration files. They kind of both found their home. I don't exactly know what discussions took place where it just kind of happened, probably just naturally happened. As groups of developers migrated towards their favorite format, I don't know. But anyway, config files, a lot of times are YAML files. So let's go through this file. First line, specify the version of Docker Compose that you want to use. So certain features in Docker Compose are only in certain version numbers. Just tell Docker Compose what version number you wrote your file in. Yeah, I don't have anything else to say about that. Let's keep moving. And then you're going to have your services. This is which apps you want to run. And each one of these, and what containers you want to build, what images you want to build, what containers you want to run. And for this, we're going to run 2 of them. I'm going to run a Mongo database and my app. So I have 2 services that I'm going to run. This is going to create 2 Docker images. It's going to create 2 Docker containers and then run my app with both of those containers. So we have 2 containers running. And this is how we would start building distributed systems. You could have hundreds of these things. You have hundreds of apps all communicating to each other. You want a microservices architecture, you could tie it all together with Docker Compose. Have Docker Compose run all of those apps, and then they can start communicating with each other. So there are 2 apps, and we're going to name them. And these names are important. These names are going to be the host names for our apps. So for example, I just named my database Mongo, my database container. So now when I connect to it, instead of using localhost, I'm going to use Mongo. That's the host name. And that's how multiple Docker containers can communicate with each other through Docker Compose, is through these host names. These names of the services are the host names. If for some reason my database needed to talk to my app, I would connect to app instead of localhost or 0000 or 127.100. I would connect to that name. That's the host name. And then Docker Compose will handle the routing from there to get to the right container. Each of these services are going to be an image, a Docker image. For Mongo, I'm not going to bother with a Docker file. I could specify a Docker file, but I don't need to. I'm just going to use vanilla vanilla MongoDB. So I'm going to specify the image, which is the same as saying from a Docker file that has one line that says from Mongo 425. I'm just going to use that out of the box, and I don't have to change anything with it. If I wanted to, I could add more here. I could change it. I could define a whole Docker file. I don't need to do any of that. I'm just going to say, give me Mongo. Just give me vanilla out-of-the-box Mongo. For my app, I do want a Docker file. We're going to use the Docker file we saw on Wednesday. And you need to specify the directory where that Docker file can be found. This is the same, and I'm just going to use a dot. This is saying the Docker file is in this directory. This assumes that my docker compose.yaml file is in the same directory as my Docker file. If it's not, I would specify the path right here. I'd say like ./app, whatever directory I have my app files in. I like having Docker Compose and Docker right next to each other, so I'll usually do that. But if we had, say, Mongo was in a separate Docker file, if I had a separate Docker file for that, I'd have to put that in a separate directory and then specify the directory for that Docker file. And most of this information is the same information we do when we run our container, when we had that -p and then port number, port number, and then the trailing dot when we build. A lot of that information is the same. We have one extra thing here, environment. This is how we're going to set any environment variables. And this is where I would have my password of change me. If I was using a password in my Docker Compose in my app, this is where I would set that environment variable. We have one environment variable that we have to set. This is very important for things to work. Your database is going to run, like Docker Compose is going to start your database and start your app. The database is going to have a pretty lengthy startup script. It's going to take a while to spin up. It's got a lot of work to do just to get to the point where it can accept TCP connections and start being a database server. It takes a while. On the order of seconds, but it takes a little while. Your app, probably one of the first things your app is going to do is connect to the database. Well, the database isn't going to be running yet. Your app is going to be immediately, okay, I'm running, okay, connect to the database. Your database is going to say, okay, I'm running, hold on, let me run my whole startup script before I can accept connections. So that connection will be refused if we don't do something here. So we need some way to wait for that database to be ready for TCP connections before connecting to it. And for my money, I like this answer. This GitHub user, UFO Scout, I haven't met them, but they're fantastic because they solved this problem and just made the solution freely available. Last I heard, this UFO Scout has a pull request to actually add this to Docker Compose, to add this feature, which would be fantastic. We wouldn't have to have this as a workaround. We would just use it as a Docker Compose feature. Not sure if that got merged yet. I don't know what the status is of that. But for now, we'll keep doing this until we hear otherwise. So we're going to add this wait host environment variable, the host name and port number. I want to wait for Mongo, which has to match this, on port 27017, the default MongoDB port. And what this is going to say is wait for this host to be listening for TCP, accepting TCP connections on this port. We're going to download this wait script. We're going to change the permissions of that wait script so we can execute it. And then instead of just running our app, we're going to run that wait script that we downloaded, which literally just waits for anything in wait host to be accepting TCP connections. And then once the database is ready for connections, then this exits, and then we're going to run our app. So our app is effectively waiting for that database to be ready before starting. If you find a different solution for this, use whatever you want. I like this one. It's tested. It works. I know it works. So I recommend just using this one. Thanks, UFO Scout. And then finally, port. This is the same as your -p or -- publish, which can be shortened to just -p. And then mapping a local port number to your internal port number. So when I was covering Docker on Wednesday, I wasn't using port 8080, even though that's required on your homework. It's because port 8080 won't come into play until your Docker Compose file. In Docker Compose, you want to map local port 8080. This has to be port 8080 for your homework to whatever port you're running inside your container. This port can be whatever you want. You can use whatever port you want inside your Docker container. I don't care what that port is. But in Docker Compose, map port 8080 to that internal port. And then when we spin up your app using Docker Compose, we're going to go to localhost 8080 to access your app. And then Docker Compose is going to say, oh, yeah, that's port 8000 inside the container. We don't care what that is when we're grading, but we want to be able to access your app on 8080. You can make this 8080 and just stay consistent. That's fine. It could be whatever you want. So when you connect that Mongo client, we used to have localhost way back like half an hour ago. That's going to be Mongo. This has to match whatever you name your database service. So if you're using a MySQL image, you connect to MySQL instead of localhost, it'll be whatever you name it here. Here, I name this service Mongo. That's the host name. When I connect to that, I have to use that host name. Then when I want to run Docker Compose up. We don't have to build separately and then run all those commands. Docker Compose up, and that's it. If you want to rebuild, Docker Compose up --build. This is the command you'll most likely be typing most of the time. Docker Compose up --build is going to rebuild your images and then run your containers all in one go. All right, we only got 1 minute for this, but we got there. And once you're done with the question, you can go. I got nothing else.